Now, what is the simplified structures of these types? Let's start with the mesenchyma, which is mostly made of fibroblasts and embryonic connective tissue cells with various processes. This connective tissue is highly vascularized, so we got capillaries lined with endothelial cells there. We got reticular microfibrils and fine collagenous microfibrils providing support for the cells and the capillaries, and there are amounts of glycosaminoglycans in the ground substance. So we got the mesenchyma cells, mostly fibroblasts. We got capillaries, extracellular matrix fibers, mainly reticular, and fine collagen fibers. And we got the ground substance of the extracellular matrix. An example is the embryonic connective tissue. Very similar, it's mucous connective tissue. The difference is rather quantitative, and it also contains fibroblasts, occasionally fibrocytes, the resting forms. There are capillaries as well. Okay. They are reticular fibers, but what makes the difference is really a huge amount, a huge volume fraction of the ground substance, and predominantly the hyaluronic acid. So we got fibrocyte, here we got fibroblast, we got capillaries, and we got huge amounts of ground substance, mainly hyaluronic acid. Which binds lots of water. You can find this mucous tissue surrounding the umbilical arteries and umbilical vein in the umbilical cord. That's where you call it Wharton's jelly. And you can find this type of connective tissue in dental pulp. Okay, let's proceed to loose connective tissue. Loose collagenous connective tissue. The prevailing cells are fibroblasts, so those with the euchromatic nuclei, but you can also find fibrocytes with the heterochromatic nuclei. There are blood vessels again, lined with endothelium. And these blood vessels are sources of migratory connective tissue cells, such as plasma cells, plasma cells with their pyramid-shaped form, clock phase distribution of chromatin, and well-developed granular endoplasmic reticulum responsible for the basophilic properties. You can find macrophages there with their irregular shape of the cell, irregular nuclei, and many lysosomes and vacuoles, phagosomes, phagolysosomes of partially or completely digested substances. You remember perhaps the mastocytes or heparinocytes with their granules containing heparin and histamine that could be potentially released. And there are other cells such as white blood cells migrating out of the capillaries, such as lymphocytes with their round-shaped nuclei, or very often neutrophilic granulocytes with their typically segmented nuclei. The loose collagenous connective tissue contains only small fraction of fibers, mostly reticular and collagen fibers again, and there are amounts of the extracellular ground substance. Together with the tissue fluid that promotes circulation of nutrients and all chemicals through the tissues. So let's label the cells. We got the fibroblasts, we got fibrocytes, we got blood vessels, we got plasma cells, we got macrophages, we got heparinocytes or mast cell, we got lymphocytes, very often, lymphocyte, and we got neutrophils. The fibers are predominantly reticular and collagen fibers. Especially thin fibers, and there is a large fraction of the ground substance and with the tissue fluid. Well, what makes loose collagenous connective tissue a loose collagenous connective tissue is that the cells and the ground substance prevail over fibers. So the fibers represent the minority of the tissue. Examples from the human body, you can find this loose connective tissue forming the lamina propria of mucosa in GIT, in genital system, in urinary system, in respiratory system, and also the submucosa in GIT. Well, if there is loose collagenous connective tissue, there will be probably also dense collagenous connective tissue. Yes, there is, and the fibers here predominate over cells and ground substance. If there is one prevailing orientation, we call that type regular, dense, collagenous connective tissue. We got very thick bundles of type 1 collagen fibers with one preferred orientation, tightly packed very often, leaving only little space for other tissue components, such as fibrosides, these are the resting forms, or the more metabolically active fibroblasts. This difference could be mostly seen by the nucleus. There are blood vessels as well. Every connective tissue is vascularized. However, the fraction of the ground substance is small. So we got thick bundles of type 1 collagen fibers. There are capillaries, fibroblasts, fibrosides, and only small amounts of ground substance. Low fraction of it. This is how our tendons look like. So examples could be tendons, ligaments, aponeurosis, and diverse fascia. What if there are more than a single prevailing direction? Then we call that type irregular, dense, collagenous connective tissue. And the composition is pretty similar, but there are diverse directions of these collagen fibers and bundles of collagen. So more orientations are represented in the tissue, and you cannot precisely tell which one predominates. So there's a whole network of collagen fibers. They do not branch, but they might overlap, and the gaps are filled with mostly fibrosides. They might be fibroblasts indeed. And again, we got blood vessels. There. Capillaries. And again, only small fraction of the ground substance in the gaps between. So, again, the bundles of type 1 collagen, they run in various directions. Well, here there was one direction, one prevailing direction. There are capillaries, fibroblasts, fibrosides. And again, small fraction of ground substance. This is a typical orientation or typical structure of the reticular layer of dermis of human skin, or fibrous capsules in organs such as liver, kidney, lymph nodes, spleen, thymus, etc. Other types of connective tissue are, for example, adipose tissue, and as we recall, there are two types of adipocytes and there are two types of adipose tissue. The white adipose tissue consists of unilocular fat cells, unilocular adipocytes, cells with nuclei compressed somewhere on the periphery, because most of the cell is occupied by single large lipid vacuole. This has been dissolved and flushed away during the histological processing, so in routine sections you are looking on empty cells. In the extracellular space there are many capillaries, and the cells are supported by a delicate network of reticular and collagen fibers. There is only a small fraction of ground substance. So we got these unilocular fat cells with that single lipid droplet, the nucleus is eccentric, there are blood capillaries, fine reticular and collagen fibers, and only small amounts of ground substance. While the brown adipose tissue consists of multilocular fat cells where the nucleus is very often closer to the cell center and the total load of the lipid vacuole is distributed into hundreds of small droplets or vacuoles. The vascular bed of brown adipose tissue is even more dense than in white adipose tissue, so both types of tissue have a high metabolic rate, but brown adipose tissue has more vessels. Again, there are these supporting collagen and reticular fibers. And interestingly, the multilocular adipocytes receive a nerve supply from the second neuron of the sympathetic part of the autonomic nerve system. So if this would be the first neuron of the sympathetic pathway, sympathetic innervation is the first neuron, and this will be the second neuron. Then there is a synapse here releasing a neurotransmitter called noradrenaline, and the response upon adrenaline is burning the lipids and producing heat, which is called non-shivering thermogenesis. This corresponds with the distribution of this brown adipose tissue. It's mostly in newborns, in specific areas such as interscapular region, the mediastinum region, or around the kidneys. During aging, it disappears. Most of the body adipose tissue is made of the white adipose tissue. I would like to point out that there are really many capillaries here. Don't consider adipose tissue as only a reservoir of lipids. It's highly metabolically active tissue with many physiological functions. Okay, other type will be elastic connective tissue. A good example of elastic connective tissue would be the structure of elastic arteries, such as the aorta, where we have a whole network of elastic membranes. These membranes have openings called fenestrations, and the major elastic membranes are connected with each other via elastin crosslinks, which forms a whole network occupied by vascular smooth muscle cells that are spindle-shaped, and they are producers of this matrix. They have a centrally positioned nucleus, always. Yeah. They are also fibrocytes, fibroblasts, and there are some amounts of collagen fibers as well, mainly type 3 collagen, and glycosaminoglycans as well. However, what's characteristic here is the network of the black network of elastic fibers and whole membranes, which are two-dimensional structures, not just one-dimensional like fibers. These membranes have openings called fenestrations, so we call this fenestrated membranes. And in these openings you can find vascular smooth muscle cells or fibroblasts and fibrocytes. Okay. An example would be the tunica media, the middle layer of elastic arteries. Elastic arteries are those that are the closest to the heart. So it's the aorta and pulmonary trunk. Elastic connective tissue in the different form without these vascular smooth muscle cells occurs also in yellow ligaments of the spine of the vertebral column. Another type would be reticular connective tissue. You might recall that it's made of reticular connective tissue cells with their long processes that in 3D make a network. These cells are supported by reticular fibers, these type 3 collagen fibers, produced by these reticular cells and embraced by their cell processes. Again, we got blood vessels here. So we got the reticular cells, reticular fibers, we got blood vessels, and this occurs in lymph nodes, in the white pulp of the spleen, in the lamina propria of tonsils, and this reticular connective tissue is found as a supporting tissues in organs such as lungs, or liver or kidney. That's where we call it interstitial connective tissue of these parenchymatous organs of lungs, kidney, or liver. In case of these lymphoid organs, such as lymph nodes, spleen, etc., the lymphocytes, which are round-shaped cells, mostly filled with round nucleus, are infiltrating this supporting network. And they might infiltrate it in such a dense manner that they completely hide the structure of the reticular connective tissue, because they are intensely stained. So that's making it quite difficult in real microscopy observation. So this was the simplified schemes of various types of connective tissue that you might find helpful once discovering the real structure using the microscope. Goodbye.